in Scotland. He started his career with the National Highways Board in Pakistan. You worked in the US with Bechtel Corporation and has worked on international airport projects. In '95, he joined the Saudi Bin Laden Group, where he's worked as an expert on airports and roads. And now you're the project director for a key section of the North-South Railway for the Bin Laden Company in the Kingdom of Saudi Arabia. I've heard Dr. Khan talk before, and I know that the one thing you can really be sure of is he'll deal with the practical issues. And I'm looking forward to hearing how many camel crossings you've put in so far into the rail network. But please, Dr. Khan, the floor is yours.
Thank you, Mr. Chairman. Ladies and gentlemen, it's a pleasure to speak here, and it's a pleasure for me to be in Muscat for the first time. I had heard so much about it, and I find it really fascinating place. First of all, I think Dr. Ramis and already they have dwelled on the network in Saudi Arabia. Saudi Arabia has already some of the network completed, and that is North-South Railway, and then the Makkah Medina, or Jeddah Medina, which is a Haramain, is under construction and shortly will be completed. We had the good fortune to work on CTW 100, which is a section which starts at Zabira Junction, where the bauxite mine is, and goes up to Ras Al Khair, which is the coastal industrial city, where both bauxite and phosphates are going to be processed. At the moment, the middle train is running from Hazm al-Jalamid and bringing phosphate up to Ras Al Khair for processing. So we are responsible for the construction of the last section, which is called CTW 110. Now, just to give you the volume of work that we had, as you can see, the length of this section was about 740 kilometers, and we had earthwork about 42 million cubic meters for the main track, and we had roads, that is bridges and camel crossing, the chairman just mentioned, was another 6 million. Altogether, you can see there's a lot of work which had to be done, and it was quite a task to do it in a matter of 4 years, in a period of 4 years, and with the climatic conditions and other challenges that we had. So I will briefly run through what we had to do, and what are the difficulties that we faced. First of all, when I started on this project, and I was talking to a lot of who's in the railway industry, and I was always surprised that the first thing they talked about in a railway project was the logistics. They said, absolutely, logistics is the most important thing. And shortly after starting the project, I learned that was very true. We had to bring in rails. We had to bring all other accessories for the track work. We had to transport a large quantity of material from the crusher plants to the site for the ballast and sub-ballast material. We had to set up the camps for the large number of people, almost 4,000, who had to be located on site and they had to be provided food and all other essentials for living there and being comfortable, because without taking care of that, you cannot expect people to perform to their maximum. We set up 3 large camps, which were the main camps, and then we also set up several smaller camps to augment the facilities as we moved from one area to another for different parts of the work. And therefore, these were called, sometimes they were called flying camps. Communication, this was the area where the communication was not very good, and therefore the mobiles did not work all the time, and therefore we needed a reliable communication system for the track work, track operation. And for that, we decided to make our own communication system, which comprised of a number of towers which were strategically located, and these were our main backbone for the communication for the operation of work trains, and later on when the mineral train started, it also was utilized there. Earthwork is, as you know, is a major activity, and we had challenges of doing the excavation, cut, and also fill, and in some areas, and sometime, unexpectedly, we found rock which had to be either ripped or blasted. Subballast is the layer which goes on top of the subgrade. In terms of pavement for the railway, it is a layer which is just below the ballast. We had some areas which had a problem of soil stability, and these areas were in between, and they had to be stabilized, and we adopted the technique which is called dynamic replacement. And in this technique, as you can see, a pounder is dropped from about 15 to 20 meters, and this pounder is the weight of about 15 tons, and it creates this crater, and that crater, the crater is actually backfilled with sand, and we keep doing that, and this creates sand columns, and this is done at a grade of 5 meters, and then there is a one hole in between, so at the end we have a grade of about 4.5 to 5 meters, and this actually stabilizes the weak silty soil with the high water table and creates a stable base, a foundation for rest of the pavement. The reason why it is done like that, because it costs a lot of money, but in the railway, the tolerance for settlement are very, very small as compared to any other road, because you can easily repave the road. But here, the whole thing has to be dismantled, or if there is any substantial settlement. We had a number of bridges and also culverts. These are rather large culverts and these were through embankment which we had to make through a wadi, about 30 meters high embankment. We had about 15 bridges and 11 camel crossings. The bridges are mostly precast girder bridges. And this is the camel crossing. And later on we had put also lures which allows, which obscure the view of the line. Otherwise, the camel will not go across. Track work, which is the main activity. This is the inside view of what is called sleeper factory. That is where the sleepers are cast. This particular sleeper factory was one of the largest sleeper factory. It produced more than 3,000 sleepers per day. This is the yard where the rails are stocked, and these rails, which come as 25 meters length, they are welded to make a length of 250 meters, which is called long welded rails, and those are the ones which are placed on site. This is the equipment which is used for track laying, and this is a track laying machine which places the rails on top of the sleepers. First, sleepers are placed at an interval of 60 centimeter, and then rails is pulled over it, and then it is fixed in with the fastening system. Due to the shortage of time, the work of track laying was done both during the day and night, and that was very essential, because one of the things that which was unpredictable was the weather condition, and at several times, as you will see further down, there had been numerous very strong dust storms which inhibited us to work not only for a day but for a number of days. So therefore, to make up, we had to work day and night to stay on target. We, as part of this project, also built a big marshalling yard. Marshalling yard is where the rails, the train comes in. It is broken into the wagons which can go on, and any of the wagons which after inspection are found that they need some repair, they're taken out. And this now has a big workshop where the wheels can be regrind, and also any repair which needs to be done to the wagons or to the locos, it will be done in that area. Siding track, since it is a single line, we have about 8 sidings. Sidings are where the trains can pass, and also if there is any need for stabling the train, it can be parked there, and if there is any repair to be done. So again, the track in the marshalling yard. As you can see, it's got number of turnouts. The whole line is fenced to make sure that there is no encroachment. But there were a lot of challenges, as I said, making this high embankment. It was a big challenge because we had to have the continuity of track placement, and when it came to this area, we had to work very hard. Almost a lot of our earthwork equipment was deployed there in order to make sure that this gap in the because it was a part of a wadi, that this gap is completed before the track work, track laying machine arrives there. As I said, sand is a problem, was a problem during the construction, and even now, while we're trying to maintain it with the traffic running, it is a challenge. And I think this is something which every agency should take it very seriously in this region. And there are a number of ways of mitigating the sand encroachment onto the track, and we have tried some of it, and I think a lot of people are actually benefiting with the experience that we had in terms of mitigating the sand encroachment, but nevertheless also improvement can also be made. Slab track is one of the options which can be considered. As you can see, the visibility really drops during the dust storm. And that is at night. And you can see how much sand is there. It is almost like, you feel as if it's like a ship in the ocean. Both sides you have water, and you're trying to keep the water out of the boat. Sometimes, the sand comes very suddenly, and we even have to use manual labor to remove the sand. We use the brooms, and in order to mitigate the sand, we have used the fences. This is one of the machines which cleans the sand in between the track. And sometimes if a lot of sand has been collected on the slope, then the greater it is removed. We have also made the dikes on both sides of the track, in the embankment area also, in order to have the obstruction to the sand movement way before it reaches the embankment and the track. Surprisingly, we found, contrary to what generally one thinks, that in a cut area, you would think that more sand will accumulate on the track. We found out that in the cut area, there was very little sand in the track. And I think one of the reasons was that we decided that when we made the cut, especially the rock cut, we left the material which came out of the cut outside as a berm or as a dike. And that has worked perfectly and has kept the track clean. We have quality control people, inspection, but these people also decide to come to inspect our track once in a while. Alhamdulillah, now the track is being used for more than a year, and it is really very fulfilling for all of us to see this scene where you have about 1.5 kilometer long train, just like looking like a white line in the middle of the desert, and it's very satisfying. This is a train under a bridge, and that's on a curve. This is approaching the wadi that I mentioned, and this is in the middle of the desert. And whenever I look at it, I like to add some cowboys on both sides to give it a run. This is when the train is reaching. This is the unloading area where the wagons unload, and it's a very sophisticated system in the Ras Al Khair area. I would like to thank you very much for your attention, and I'll be happy to answer if there are any questions. Thank you.
Thank you very much. I think we've got time for just one or two quick questions if people want to raise them. Otherwise, Dr. Khan will be with us on the panel. So this gentleman here would like to raise questions. You need a microphone.
Dr. Khan, you just briefly mentioned about the slab track in the desert. What makes you think now, after having completed this project now in the sand dunes, do you think ballastless track would be a better solution? Now you have 1.5 years of operating experience.
Not all the way, but I mean there are some sections where slab track will be more appropriate, because slab track is easy to clean as compared to trying to get the sand out of the ballast. So in some areas where there's the track is inundated with sand. So from both, from the commercial point of view also, it will be perhaps easier to clean the sand on a slab track.
Okay, there's a question. Yeah.
I have, maybe 2 or 3 maximum questions, and maybe we were privileged to come with the GCC member states, and we had a visit to this package for construction, and Dr. Shahid was actually very generous with us, and they included lunch but no entertainment. You know that packaging for the North-South Railway was a major issue. Should it be divided into 2 packages, 3 packages, 1, and so forth? My question in this regard, the North-South has been packaged to at least maybe 6 to 8 packages: construction, signaling, telecommunication, and so forth. From contractor point of view, what are the key challenges faced to network and link with the other packages for the overall operation of the North-South Railway? The second question also comes to the issue of ballast or ballastless, sleepers. In fact, we've done extensive work in this area, and there are no differences, actually, major or significant differences in the maintenance issue, either cost or the method of that. But the question remains to be, there is significant sand movement, and there is really still difficulty in Saudi Arabia to be able to maintain the track on time. And the case is the existing, SRO, that there has been a couple of derailment because of the sand and the sand maintenance. How you foresee the maintenance being changed or becoming more effective in a railway that majority of it's in the sand areas, Nufud, and which is very, very difficult to maintain. The last a question actually that has to do with the operations. Do we have the skills required from the nationals, or even can we train them to be able to operate the trains?
Thank you, Dr. Amos. The first question, I think interface with the other contractors has been quite good. I think we just had good communication, although we only have one common point where where we end our section and the section 2 starts. I think the idea of breaking it into different sections was quite good. I would say that one contractor perhaps would have found it difficult to do it in this period of time for about 4 years logistically, because there was, as you know, Nafud was a big challenge, and there were a lot of other things like we have